Chapter 2, Descriptive Statistics. Recall from Section 1.1, there were two branches of statistics, descriptive statistics and inferential statistics. Here in Chapter 2, we'll be discussing descriptive statistics, which are ways of organizing, analyzing, and interpreting a data set. In 2.1, we're going to be looking at a way of organizing data into frequency distributions. In 2.2, we're going to look at a couple other graphs, mainly concentrating on the stem and leaf plot and a pie graph. In 2.3, we're going to look at different measures of central tendency. 2.4, we'll be looking at measures of variation. And in 2.5, we're going to be looking at measures of position. So 2.1. Frequency distributions and their graphs. So, a frequency distribution is a table that shows a set of classes and the frequency of the count or the number of entries that fall into each of these classes. For example, if I have the numbers between 1 and 30 and I want to group them together, so I have 5 numbers between 1 and 5. I do not know if all 5 numbers are the number 1 or are they a number 1, a number 2, a number 3, a number 4, and a number 5. You don't know that from the frequency distribution. You just have the counts. Now, the frequency is the count or the actual number of data entries that fall within that class. These are known as the lower class limits. They are the smallest number that would go into that class. So the smallest number that would go into class 2 is a 6. Notice they do not overlap. So the number 5 goes here, the number 6 goes here. If we went 1 to 5 and 5 to 10, then we wouldn't know which class the number 5 went into. The upper class limits are the largest numbers that would go into that class. The class width is the difference between 2 consecutive lower class limits or even 2 consecutive upper class limits. The difference between 6 and 1 is 5. The difference between 20 and 15 is also 5. So the class width is 5. Now, in constructing a frequency distribution, you need to decide on the number of classes. Usually numbers between 5 and 20, less than 5 you have not grouped enough. More than 20 you've got too many groups and it's hard to tell a pattern. First thing you would do is find the class width. So you do that by first determining the range of the data. The range of the data is the maximum value minus the minimum value. Then divide that range by the number of classes you've chosen to have. And then round up to the next convenient number. So if you end up with 5.2 as the number of classes, you would then have 6 classes. Find the class limits. You can either use the minimum data entry as the lower limit or one number slightly smaller than that. You find the remaining lower limits by adding the class width to the lower limit of the preceding class. Find the upper class, remembering that you want to make sure every number has a place to go, but there is no overlap. And find the remaining class limits by adding the class width. Then you look at your data set and you mark a tally mark for each data entry in the row of the appropriate class. Afterwards, you count the tally marks to find the total frequency for each class. Let's look at an example. Here we have a set of 30 numbers which consist of the prices of GPS navigation systems. And let's construct a frequency distribution that has 7 classes. The first thing we want to do is determine the number of classes, which was given, and it's going to be given to you in your tests and your homework also. So we have 7 classes. Next we want to find the class width, which is the range, the largest number minus the smallest number, which is 391, divided by 7 is 55.86, round up to 56. So we'll use 59, which is the minimum value, as the first lower class limit, then add 56, add 56, add 56, and so forth to find all the remaining lower class limits. Now for the upper class limit, we want a number that comes right up to 115 without overlapping it, Clearly, 114 would be our best choice. And then you can add the class width each time. Add the class width, add the class width, add the class width, add the class width, to find the remaining upper limits. Then you go through your data set and you just make tally marks. For every number that's between 59 and 114, you put a tally here. For numbers between 115 and 170, you put tallies here. Then count the number. Here we had, it says 5, but I believe this line up here belongs up here with this. So there's 5. Here we have 8, 6, 5, 2, 1, and 3. If you add up the frequency, they should sum to the total number in your sample, which in this case was 30. Let's find the midpoint, and that's another important value that's found in a frequency distribution. The midpoint is the number halfway between 59 and 114. You do that by adding 59 plus 114 divided by 2 will give us 86.5. You can find the remaining ones by adding the class width of 56. The relative frequency is the proportion or the percentage of the data that you can find in a particular class. In this case, we have 5 between 59 and 114. We had 30 total, so 5 divided by 30 is 17, or 17%. 8 divided by 30, 27%. Normally you write the relative frequencies as decimals, but sometimes it's okay to write them as percents also. The cumulative frequency is a running total of all the frequencies. So you start off with 5. I don't know why this says 6 over here. I'm sorry. 5 plus the 8 gives me 13. Then plus the 6 gives me 19. So here we have what's known as an expanded frequency distribution. It is our classes, our frequencies in each class, the midpoint for each class, the relative frequency. Now also, if you add up these numbers, they should sum to 1. If you've done any rounding, it may be just close to 1. And the cumulative frequency is adding each one. You had 5, then 5 plus the 8 is 13. 5 plus 8 plus 6 is 19. 5 plus 8 plus 6 plus 5 is 24. When your last entry should be the total number in your sample. Now, often you've heard the term "a picture tells 1,000 words." A frequency histogram is a bar graph that represents the frequency distribution. Notice the horizontal scale would be our classes, and our vertical scale is the frequency. Consecutive bars must touch. Now, in order to do this, we need to come up with another measure known as the class boundaries, so that we can separate the gaps between the classes. So, for example, the distance from the upper class limit for the first class was 114, and the second class, the lower class limit of the second class was 115. The difference between 115 and 114 is 1. Divided by 2 is 0.5. So we're going to subtract 0.5 from every lower class limit and add 0.5 to every upper class limit, and that will give us the boundaries. For example, 59 minus 0.5 is 58.5. 114 plus 0.5 is 114.5. When we subtract 0.5 from 115, we will get 114.5. Now my classes will be touching. So here are the class boundaries for our example. If we put those class boundaries on the horizontal scale, so this little hash mark over here tells you that you have you're not starting at 0. What we put in here is the midpoints, but this over here is the class boundary for class 1, and this rectangle ends at the class boundary, the upper class boundary for class 1. Then the frequency of 5 and 8 and 6 and 5. So the bars are the height of the frequencies. Right? So what we can see here is more than half of these cost less than 226.5. Here we have the same frequency histogram using the class boundaries instead of the midpoints. It is conventional to do either one. A frequency polygon is a line graph that just emphasizes the change in the frequencies. In other words, really all I needed to know from that frequency distribution is the height. So why not just go ahead and put a dot at the height? And this is the midpoint for class 1, and there was 5. It was 5 in that frequency. So instead of putting the whole bar in here, I just have a dot to represent the height of that bar, of that class. So we can see that it kind of increases until we get to 142.5, and then the number of navigators costing more than that start going down again. A relative frequency histogram is the same as the frequency histogram, except my vertical scale, instead of being frequencies, are the percents. So remember, here are our relative frequencies. So instead of over here having the 5 and the 8 and the 6, we have the relative frequency. If you recall, the relative frequency for class 1 was 17%. So this bar is at the 17% mark. Cumulative frequency graph is also known as an ogive, and it, again, you're putting a dot where the bar for the cumulative frequency is. The upper boundaries are marked on the horizontal scale, and the cumulative frequencies are here. For our example, remember we started at 0 and we went to 30. So you construct the frequency distribution, include the cumulative frequency as one of the columns. Then the horizontal scale consists of the upper class boundaries, and the vertical scale measures the cumulative frequencies. Plot the points that represent the upper class boundaries and their corresponding cumulative frequency. Connect the points in order from left to right, and the graph should start at the lower boundary of the first class and stop at the upper boundary of the last class. Remember, the cumulative frequency in the end is equal to the sample size. So here we had our cumulative frequency, 5. Then we did the 5 plus the 8 and got 13, plus 6 and got 19, and so forth. So started at 0, then we had 5, then we had 13, and so on until we ended up at 30. From the ogive chart, you can see we have the most increase in price up until about here, then it starts leveling off. That's the end of 2.1, so you should be able to interpret a frequency distribution. You should be able to construct a frequency histogram and a frequency distribution and the various graphs. Go now to my math lab and complete the homework for 2.1.